Welcome back to Climate Responsive Architecture videos part number 6. Last video we were actually seeing about this same chart, how to find out relative humidity. So just a small glance of it. So this is a chart to find out the relative humidity. Of course, you have on the left side you have the dry bulb temperature, where you can see the dry bulb temperature, it is almost like 30 degrees to 34 degrees, and on the top is the number of degree differences between the wet and dry bulb readings. For example, we have seen in the earlier charts like the dry bulb temperature is always higher and we know the wet bulb temperature is always lower. So for example, if there is a dry bulb temperature of 30 and the wet bulb temperature is almost minus 26, so the depression or the difference is going to be 4 degrees Celsius. So that's given here. So if you mark from here to here and mark from here to here, you will see you will get a relative humidity which is about 73%, which means that it is having a lot of moisture content in the air. So that's why the humidity levels are a little bit higher. So if the relative humidity is between it is considered best if it's between almost like 40 to not 40, it is considered best if it is between 50 to 60% or maybe 45 to 60%. So it's the medium where the human can feel very comfortable, neither it is too moist or neither it is too dry, etc. So this is the way we can find out the relative humidity. The next one is, as I told you, like it is a very interesting chart. It's called Mahoneys Table. So there is a set of tables which we have to fill up all these items. So you will get after filling all these things, you will get certain recommendations. So according to the recommendations, you can know what type of design can be incorporated or what type of design can be executed for the certain climatic locations. So the basic data has to be collected from your internet or maybe from your authentic source of books, etc. So for example, you get the locations, latitude, longitude, altitude, etc. You will be able to get this monthly mean maximum and monthly mean minimum, which is the day and night time temperatures. So you have to be very clear, maximum is daytime and night time is minimum. So you get an average of this, so we will know how to calculate all this. Then you will get a high and low. You will get AMT, which is annual mean temperature. One is AMR, which is annual mean range. So this table is actually in the book called Manual of Tropical Housing. The author is O.H. Koensberger. So you can go through the book, and if you see the book, there will be certain steps which they have given and explained you how to do the calculations. So you will get the few data about relative humidity. Of course, sometimes you will not get this AM and PM. So you can get an average of relative humidity for all around the here. So you can get that. So because of by finding all these things, you will get into know what type of group it is falling under. So you will also get data about rainfall, the wind, etc. And with all these data, you will go to the table number 2. You will fill up this table number 2. And with all these data, you will get this thermal stress day and night. By knowing all this thermal stress day and night, you will get the data here, and you will actually tick here like how many ticks are going to come. You can see this data. So according to this chart, okay. So that anyway, I'll explain you about this in the next forthcoming charts. Then you will get the next table, which is going to give you a lot of recommendations. So there is every table there is going to be one tick which is going to give you a lot of recommendations of design. So it's maybe like it will recommend you a layout like compact courtyard planning. If it's a spacing, so it will recommend you like what is the compact layout of spaces, air movement, openings, walls, roofs, outdoor sleeping, rain protection, etc. So this is again a little bit of intricate or in-depth recommendations which will be recommending. So if you see, this is an example of our student who has done the Mahoneys table. So you can see she has done it for Visakhapatnam. So you can see her. So she has done this monthly maximum and minimum. Of course, she has found out the range. So it's divided by 2, and again you have high and low AMT. She has found out the relative humidity. So if the relative humidity falls between 50 to 70%, it comes under the group number 3. So 69, so it comes under group number 3. If it falls above 70%, it comes under group number 4. So it is actually written as 4. So she has written the data of rainfall, the wind prevailing, etc. Now if you see again the annual mean temperature, if it's over 20 degrees Celsius, so we have to consider this chart. If it's from 15 to 20 degrees Celsius, this has to be considered. And if it's below the 15 degrees Celsius, this has to be considered. So if you see, basically the AMT is almost 27 point something like that. so 27.1, so which is actually more than 20 degrees. So what you'll do is you will take this this portion of the chart. Okay, so now you will try to incorporate this here. For example, if it's January, so monthly mean maximum is taken from here, from 28.9, it's already there. The monthly mean minimum is taken from here, so 18, you will come here. Okay, now what will happen is you will find these two results. Now it's giving you AMT is more than 27.1. so what will happen is you will take this chart. Okay, so we have to see what group it is falling. So for example, it's falling under group number 4. So January is falling under group number 4. So if it's falling under group number 4, we have to see what is happening in group number 4. It says daytime it is going to be comfort levels, or it's called thermal stress, which is 22 to 27. So it's given here, the lower is 22 and the upper is 27. And during the night time it is already done, it is 17 to 21. So again it is put here 17 to 21, etc. So now by comparing all these charts, okay, now you will find out like which is hot, which is comfortable, and which is cold, whether the daytime is comfortable. So if this minimum is falling under this, or it's falling above this, then you will get hot or something like that. So you will know about this in your next sessions of doing it. So you will now find out which is hot, which is comfortable, which is cold. Since Visakhapatnam, of course, it's a little bit of hot, humid place. So you can see like it's most of the things are thick here on the top level. So it says air movement is very essential here. So this is the way you have to start filling your Mahoneys table. So after this, again you will get all these ticks. So you will find out 10, 0, 1, 2, 00 is there. Okay, you can find out all this. So what will happen is, so you will find out all this and you will write it here. So all this can be written here, and this will find under some categories. So it will fall under some category. For example, 10 is here. So this is falling under the second category, which is 2 to 10. So it says protection of hot and cold wind. So maybe it is like that in winter also. So maybe it is protection is needed. So maybe what will happen is again you can see this chart, 2 is falling under this category. So in the walls 0 to 2, so light walls with short time lag is better. So you can write it as light walls, which is better. Okay, it's warm humid place, so maybe it is already having a humidity, so light walls are recommended, so that the heat transfer can be left out easily in the evening, because maybe the breeze is more. So like that, so you will come into some certain design conclusions or design ideas by doing the Mahoneys chart. This was the first basic chart which was initiated by Mahoney, or which was done by Mahoney, so that people can use it to get a clear idea of how you can proceed with the design ideas. Thank you. And a few more, whatever the recommendations which are here is actually done as sketches by our students. So generally, again, 2 students works are there. So again, one is like what is the type of orientation which you have to do, what is the type of spacing which you have to do, and again another student's work for New Delhi, she has done like what is the position of opening, what is the type of spacing which is recommended. So whatever is done in the previous charts, so layout, spacing, air movement, all these are converted as sketches, because an architect can better deliver items in through sketching, architect or a designer. So and you can understand better also through sketches. So that's the end of Mahoneys table. So after the Mahoneys table, then slowly there is some kind of initiation or some kind of chart which was done by Olge. Olge is the person who has initiated this chart. So if you see, this is actually a comfort chart, which is also called as the Bioclimatic Chart. So what happens in a Bioclimatic chart is, so we generally know the comfort zone by means of little bit of subjective responses, like we know that people are very comfortable at a certain degree of about 20 to 25 degrees Celsius. So this comfort zone is actually marked by means of subjective responses, and of course we know beyond 27 degrees or beyond 28 degrees it's little difficult for the people to feel thermally comfortable, and below 20 degrees they feel very cold. Now in a bioclimatic chart, what happens is we get general data about temperature every day, and about relative humidity also every day and every hour. So what happens, you are supposed to plot the points every hour. So for example, by today at 10 o'clock to 11 o'clock, if the temperature is about 23 degrees Celsius, so maybe it is like 23 degrees Celsius here, and if you imagine that the relative humidity is going to be a little bit higher, so maybe like 65%, so maybe like it is 65%. So at morning 10 o'clock it is very comfortable because it's falling under the comfortable zone. So maybe at 3 o'clock during the afternoons, so maybe the temperature is raised to 32 degrees Celsius, so it will be somewhere here 32 degrees Celsius, and the relative humidity will be very less, so maybe the relative humidity is almost like 40 degrees Celsius or 40%, so your points will fall here. So what happens is here the recommendation generally given is the wind is supposed to be needed, because when you have a relative humidity lesser, so if you try to induce wind or if you try to provide a natural ventilation or an artificial ventilation, okay, so you will be bringing the comfort inside, so you will come and sit inside the comfortable zone, okay. So that's why the wind is needed. As you go, the temperature is higher and the relative humidity is lower. Again, if you come to night, okay, for example, if you are in a little bit colder region, okay, so during your night, so maybe it is like only 15 degrees Celsius or something like 18 degrees Celsius, and relative humidity is little higher because it goes to 80% during the night because the moisture becomes higher. So again, it is not falling under the comfort zone, so people need a little bit of warmth, or maybe they need sunshine, or maybe they need a little bit of heat. So maybe in the night you cannot bring in sunshine, so what happens is we try to give heaters, etc. Fine. During the daytime, if it's a very cold zone, for example, if you have about 18 degrees Celsius and again the relative humidity is almost 60%, okay, so what happens is the sun's radiation is needed little more inside the building to make you very comfortable. So we try to give you a little bit of glass facades, etc., so that you bring in a lot of heat inside the building in a colder zone, So again, here it's the limit of work or it's too sultry, so points falling there will be very high. So now you can see some few charts like January, so the points falling from day and night, day and night, day and night. So you can see the points will vary day and night for every hour. So we have about 8,760 hours. So we have to plot about 8,760 hours of points so that we can understand an average value of how much of points are falling under the comfortable zone. So maybe like 3,000 hertz or 4,000 hertz. So people are feeling very comfortable. So you can find out like so in this climatic zone, so people can feel comfortable of about dash hours. So maybe it can be done month wise also, so we can understand in which month they are feeling very comfortable. So maybe in January, maybe in February, maybe in September, August, etc. Again, the months are divided into summer, winter, autumn and spring. So we can understand by means of months also. So this is one of the charts which explains you or which gives you the data of about the comfort zone. Now these values which you are supposed to find out, the temperature and the relative humidity values, are available in the internet or in the web, and it is actually a data which is given by IMD. IMD is nothing but Indian Meteorological Department or any meteorological department in the world. So IMD is the authentic body who is actually giving you the data. So try to find out an authentic data of the whole year and try to plot the points here so that we can understand how the comfortable hours are there in certain region. So this is the bioclimatic chart. So next thing is a little enhanced. So after the bioclimatic chart, there was something called as a psychrometric chart, in which in the previous chart you can see the temperature was on the y-axis and the relative humidity was on the x-axis. Now if you see the next chart, the x-axis will have the dry bulb temperature and the y-axis is going to have the absolute humidity, and there is a small curved line, okay, it's a thin curved line which is also called as the relative humidity. So we understand relative humidity is the proportion of AH by SH, that is absolute humidity divided by the saturation humidity, which is given in the percentage, so 100%, 80%, etc. So these curved lines are called as the relative humidity lines, and there is a little bit of slanting lines which is also called as the wet bulb temperature, So these lines which are projecting out from the x-axis is called as the dry bulb temperature, and these horizontal lines are called as the absolute humidity. So this slanting lines are called as the relative humidity. So 100, 90, 80, and we have 70, 60, 50, 40, 30, 20 and 10 degrees, it's very low. Now this blue color line is called as the comfort zone, and these green points are called as the hours, that is 8760 hours. Now this is marked in Jaisalmer, so it's a small typical example. Actually we can go through this software. We are going to explain you another video regarding the software itself. So if you see the lot of points in Jaisalmer, it's a very hot and dry region. So you can know like it's going beyond 40 degrees Celsius. So the temperature is very high. The humidity levels are a little lower also in Jaisalmer. In few seasons, that is maybe in January or February, the temperature is little lesser or very less also to 10 degrees Celsius, and the humidity levels are also very high. So since it's a desert region, so you will have both the types of the variations of climate. So there will be a lot of diurnal variations, which means the daytime can be a little hotter and the nighttime can be a little lower. This software, now this psychrometric chart was done manually. Now the climate consultant software is actually giving you the psychrometric chart by means of inserting a data called EPW data. So now climate consultant is the software, so we can see about climate consultant later. So this software is a very good software which gives you the whole picture of the climate, okay, and it also gives you the types of strategies which can be incorporated to maximize the the thermal comfort. Okay, so that is the way it is trying to do it. So we can see about it. So this is the region of comfort zone. So if you have this green color, for example, natural ventilation. So if you use like almost like 3.8% of natural ventilation, you can bring in more comfort. So this is called internal heat gain. That means it's cold. So if you want to bring in little bit of almost like 16% of internal heat gain, if you put something like if you use a lot of thick walls or etc., or if you use little bit of fireplaces etc., you can gain heat, or maybe by means of using glass windows. So this will actually give you more comfort. So this is the way we are going to see the psychrometric chart in the later slides. So again, there is something called as ashtray standards, American Society for Heating, Cooling and Refrigeration Air Conditioners, and this ashtray standards is actually giving you a standard of comfort zone. So this is the standard of comfort zone, which starts from 23 degrees to almost like 27 degrees Celsius. So this comfort zone varies if it's like 1.0. It also gives you the clothing level. So as we saw, what is the metabolic rate and what is the clothing level. So it is also giving you the clothing level. So if you are points or weather data points, if it's falling under this category, it means you are feeling comfortable during the winter and also in summer. So 0.5 is almost for the summer, so your clothing level is lesser. So 1.0 is for the winter. So if your points are falling here, and if you wear a suit or whatever it is, and you will feel comfortable. Generally it gives you operative temperature, or sometimes it gives you the dry bulb temperature also, that we can see later in later sections of the slides. So now if you see, like if it's if the lot of data points are falling under your right side of the chart, it means that it's an orange color. It means the region is too hot. So if for example we saw about Jaisalmer and Jodhpur etc., it's hotter regions in India, and if your points are falling on the left side of the chart, so it means it is too cold, maybe like Shimla, maybe like Shillong etc., so they will fall under this. Maybe if the points are falling on the topmost corner of the topmost right corner of the chart, it means it is humid. So maybe like Chennai and few regions like Chennai etc. So now this is the chart which is actually showing you a lot of humidity, okay, and if it's falling under this, so for example yellow color, if it's too dry, so maybe some desert climate. So if a lot of weather data points are falling under this, so it is like too dry. So you can understand by the next chart, which is actually here. Can you see if the points fall here, it's cool, it's little moderate, which means we feel comfortable. It's warm dry, hot dry, it's hot humid and warm humid. So it's almost, you can see how the data point will actually give you the exact climatic aspects of the location. So you can actually see what type of systems can be used, okay, if it's evaporative cooling, sensible cooling, or sensible heating, humidifying, dehumidifying etc. We will explain this in the later slides also, just to understand now. So you can see comfort zone is nothing but in a bioclimatic or in a psychrometric chart, the area with the combined temperature and humidity in which 80% of the people are comfortable are specified as the comfort zone. Of course there is some kind of subjective responses also. So we find out like what type of temperature and in what climate or what humidity level you feel comfortable, etc. And it depends on the shading level, the clothing level, of course the heat, what type, how much of heat is there, and the activity, and also the protection from the wind. Okay, so this is the comfort zone. If you take so much of evaporative cooling, so you can bring in more comfort. If you do so much of natural ventilation, you can bring in more comfort, and so on. Fine. So this is the way how a psychrometric chart is going to be there, and you can just understand to this level, and later slides you can understand more in detail about the psychrometric charts. So there are a few various units and measures which you can see. So you have to know, like if it's certain things are given in Fahrenheit, how to convert it to degree Celsius, certain length, areas, etc., BTU into some other units, volumes, etc. So now these are the fundamental units. You have to just go through and find out what is the units and measure. And at last, now we have to really understand like why are we studying the subject. Okay, so now we generally understand what is sustainability. Generally everybody has got a certain word, so suddenly they say everybody today sustainable, so be sustainable. So we have to really know how you can be sustainable. Sustainability does not mean just to build a green building, but it is also a way of living. So you must know how to live sustainably by means of exactly using the resources which are available with you, and also giving the better environment to the next generation. So that is what is called sustainability. So to sustain is the general term. It's called as sustainability. So now there is a general what you call definition which is given by the Institute of Architects or American Institute of Architects. Sustainability refers to the ability of society, ecosystem or other ongoing system to continue functioning into the indefinite future without being forced into decline through exhaustion or overloading of the key resources on which the system depends. So we have to know how the system is going on now, how to exactly use the resources which are available now, and how to provide the better environment or better resources or better facilities without losing our own identity or our own energy or whatever it is for the future. Okay, so now these are the three main pillars of sustainability. So we call it as the social pillar, economic pillar and environmental pillar, and it's again we call it as the 3 P's, which is people, prosperity and planet. So all these three have to be combined in a good proportion to get a human comfort. The yellow color is called as the human comfort. So social, so today if you see social, so we have a lot of social networking, but we are not social enough in terms of interacting. Okay, there is a lot of ways of interaction, but it is missing. Of course the friendship is also missing in a lot of the real source of friendship is actually missing in society. Of course there is a lot of economical variations are very high. It's a very vast field which you have to discuss. So we have to combine a society and an economy to find a good well-being. And we have next thing is environment. So an architect can actually concentrate more on the environment because he is actually given the choice to actually change the environment. Okay, an architect or a designer who is going to build or who is going to design and who is going to propose something for the future. Okay, for the future living. So the environment is a major aspect which is given to the architect. In such a big environment, there are small things which you can change. Okay, environment is a very large word or a large arena where you can try to change smaller things as an architect or a designer and create a better future. So this climate responsive architecture field is a very small field where which is more oriented towards the environment and also energy saving. So if you do better buildings for the environment and also do buildings which are energy saving, it is going to be very economical. So due to the betterment of the environment, the society is going to give you a better result, or the society is going to feel very happy. So according to the change of the environment, these two are also going to integrately be better in terms of your sensible ways of design. So as a sensible architect or a designer, so you try to find things like what can be done in the future, or how you can give a better building or a better proposal to a client which is more oriented towards the sustainable future. As an architect or a designer, we need to know how things are wasted. Of course, we know in the building industry there is going to be a lot of waste whatever you are going to use. Okay, so if you propose a lot of items which cannot be reused or recycled, etc., so you're going to generate a lot of waste. So waste is actually segregated into paper, glass, organic and plastic. So as a sensible architect, you must know how to reduce, how to reuse and how to recycle by means of redesign. So you have a lot of options now. Okay, so now a lot of new elements or new buildings may come up, or even an old project might come which can be come for renovation or etc. So you can try to implement your type of strategy of reusing certain things in a better manner. So that's how an architect must think as a responsible citizen for the future. So the climate is always changing, so be aware how the climate is changing, how you can adapt yourself to climate, first thing. And be aware that the materials are also going to change now, so be aware that there is going to be a lot of changes in terms of what you call the thermal capacity or the urban heat island effect, etc. So you have to know how you can develop yourself and give a better solution to the whole world. Thank you. So we have a lot of references, so it's a very important task, or a very important what do you call it, it's very important to know about the books which you are supposed to study, which are very, very authentic, because these books are referred and these books are entitled, or these books are published by means of a lot of references by the scholars. So you can see the first thing is Heating, Cooling, Lighting. It's a very interesting book. This is a very Indianized, or maybe it's a very simple book which you can go through, Climate Responsive Architecture. This is the manual of tropical housing and building types. We have Sun, Wind and Light, which is an awarded book. Okay, you can go through that. We have Tropical Sustainable Architecture. It's a set of research papers, very interesting, so you can just go through this. Green is Red is a very nice book. Anil Lal is he's an Indian architect. This is a very nice book. You have to read or go through it. How he makes very simple buildings and he makes it very sustainable, or makes it very climate responsive for the environment. So you can go through that. Of course, you can go through about site analysis, how an architect must perform his design by means of site analysis. We have sustainable building. We have Introduction to Architectural Science, which is more technical. You can know about all the technical data of psychrometric chart, your heat transfer, your lighting, acoustic, etc. in this book. Okay. So now we have some few web pages, like small. I have just given only 2 references, but there are a lot of web pages which you can go through. Okay. Thank you, and we had a nice session. We will be going through these assignments later, so we can just see the assignments which you are supposed to do. So this assignment 1 is to climatic data, which you are supposed to collect the climatic data which I have mentioned in your class. So microclimatic data, again this is the data which you are supposed to collect in certain points at inside the campus. And we have question banks. We can just go through the question banks and then kindly prepare for the exam. Thank you. Now the unit 1 is completed, which is climate and thermal comfort. Hope you had a better knowledge in these sessions. So we will actually see unit number 2 from the next session onwards. Thank you so much. All the best.